Hello everyone, welcome back to Think Sharp Ali. Today we are diving into Factorisation Masterclass Type 3. Here we will explore how to factorize expressions smartly using algebraic identities. These are like secret tools in mathematics. Once you know how to use them, factorization becomes quick, easy and super interesting. So in this session, we will break down tricky expressions step by step, and by the end you will feel confident applying these identities to solve problems effortlessly. So stay tuned, let's sharpen our thinking together. Our first subtopic is factorizing a perfect square trinomial. What is a trinomial? An algebraic expression containing three terms. But what do we mean perfect square trinomial? It is a quadratic expression with three terms that comes from expanding either a plus b whole square or a minus b whole square. So today we will use these two identities. These two are like the OG ships of algebra. So remember this by heart. Okay, and let's start our class with very simple examples, and slowly step by step we will move to higher level problems. So at first we have this expression. Now the first question is, how do we catch a perfect square trinomial? How do we identify them? In the perfect square trinomial you will find two terms which is a perfect square. Can you identify them here? Yes. The first and the last, and the middle term will be twice the product of their roots. So let's see whether the middle term is twice the product of their roots. So first we are going to write 2 into 2x into 3y. So let's multiply the numbers first. 2 times 2 4 times 3 12 and xy. Perfect, that matches. Boom. So it's a perfect square trinomial. And so we apply the identity. Since over here plus 2ab is written, so we are supposed to apply the first identity. According to this entire expression can be written on as square of a binomial, where a is your 2x and b is 3y. So we write it as 2x plus 3y whole square. Now to write it in a factor form, we write the same expression twice. Okay, let's move on to the next problem. Now we have just a minus sign over here, but stay calm. We will just change the sign inside the bracket. So again we identify the first two perfect square term. Again this is the first and the last term. So 1 can be written as 1 square and 9x to the power 4 can be written as 3x square whole square. Be very careful while writing the powers over here. The powers gets multiplied. Okay, so 3x square whole square, and the middle term, as I have stated earlier, we will not put so much of effort in remembering. We will just write 2 times 1 times 3x square, and then we will check whether it's matching or not. And see, after multiplying the numbers, we are getting 2 ones are 2 into 3, 6x square. Perfect. Now since we have a minus sign, that means it's a sign that we have to use the second identity. So it is basically a minus b whole square. A is my 1 minus 3x square and a whole square. The same thing, I'll write it twice in a factor form, and that's it. This is my answer. Can we see one more simple problem? But we'll deal with fractions right now. Can you identify two perfect squares? That is this and this one. Right, the first two terms. So first term can be written as a by 3 whole square, second term b by 8 whole square, and as I had mentioned before, we are just going to write it as 2 times the product, and then we are going to check. So 2 times a by 3 times b by 8. Now if you cancel 2 and 8, we are going to get 4. So that gives me ab by 3 times 4, that's 12. So it matches, which means since I have plus 2ab over here, that means we are going to use the first formula. So this expression reduces to just a by 3 plus b by 8 whole square. And that is this. Alright thinkers, warm up done. You have mastered factorizing a perfect square trinomial. Now it's time to meet one of the most powerful identities in algebra. Simple, fast, deadly, presenting difference of two squares. A square minus b square equal to a plus b into a minus b. This formula is extremely useful because it allows us to factor expressions with only two terms. But we can apply it only if both the terms are perfect squares and there is a minus sign between them. This one is a baby level, like literally ABC of difference of squares. First step is to spot the squares. 4x square can be written as 2x whole square and 169y square is 13y whole square. Now we plug in the identity. So this is my a square minus b square. So we write a plus b into a minus b. Boom, done, speed run level. Now we are slightly upgrading our question. Don't get scared by the bracket. It's just being dramatic. So here 1 is already a perfect square and the next part is given in a perfect square form. So it's 1 square minus b minus c whole square. So now we apply the identity. So we have 1 plus the second part, then 1 minus the second part. Now we'll simplify because we love cleanliness. So we'll remove the bracket and the sign inside will change because minus minus is plus. That's it. Now example 3. The next example, it requires a little more working of our brain cells. So if you have attended my type 2 class, you already know whenever we have 4 terms, generally we group, right? So hold up. Before grouping, I want to rearrange the terms first. Now group clever things together like Netflix playlist. So first thing is we'll take both the perfect square terms together. So here perfect square terms are x square and 4 and xy and minus 2y together. So we group it like this. In the first part we can apply formula, this formula. And the next part, you can see we have a common term, that is y. So we'll take y as common. And we are left with x minus 2. Now this part will factorized using this identity. So we'll get x minus 2 into x plus 2 and this part remains as it is. Now take out the common factor which is x minus 2 over here. And I'll be left with x plus 2 plus y, right? Now this is a challenge question for you. Look at this and tell me, are these brackets helping us? The expressions inside the bracket are not same, nothing is coming common, so zero help. They are just sitting here like useless relatives at a wedding. So let's expand them, but be very careful with the minus sign. You should distribute it like we do with Prasad. So a into a is a square minus 3a minus b into b is b square minus minus plus b into 3, 3b. Now again we'll rearrange it as we have done earlier, all the two perfect squares together. So we have a square and b square and the other two terms minus 3a and plus 3b together. Then you apply formula in one group and factorize, that is take the common term in the other group. But wait, I won't solve this one here. Why don't you finish it and drop your answer in the comments? Let's see who's awake in class today. Alright, let's move on to our next problem. 16y cubed minus 4y. Now before we jump into the formula, pause for a second. Remember our very first video in this Factorisation Masterclass series? What's the golden rule we learned there? If you see anything common across the entire expression, take it out first. And here we can clearly see a 4y is common. Now some of you might be thinking, wait, why 4y? Why not just y or 2y? Good question. If you're wondering about that, it's time to quickly revisit Factorisation Masterclass 1 because we discussed exactly how to decide what to take common. You will find the link right up here. Go check it out after this video. Now back to this problem. We will take 4y common. So we have 4y square minus 1 inside the bracket. Now these two terms are a perfect square. 4y square can be written as 2y whole square and 1 is 1 square. Now what's inside? Looks like our favorite identities territory, right? So we apply this difference of two squares formula and we are done. Clean and easy, right? Let's roll into our next question. Okay, I know this one looks extra, like it's that one question in the paper which just wants to test your patience, but we are not panicking because we have got our factorization toolkit ready. Now, if you remember Masterclass Type 2, whenever we see four terms, what is our first instinct? Grouping, right? So if we group it as these two terms, perfect square terms together, and the next two terms together, so we can clearly see we can get a y common, and these two are perfect square. So we can apply our formula here, right? But is that helping us? Let's see. So here 3x squared minus 2a whole square, sorry, that was 3x whole square. And we have applied the formula, but we do not find any common factor, right? Here we have 4a minus y. We do not have 4a minus y in the first group. So this method is not working. So we will switch our gears. Now, here's the trick. We will keep 9x squared as it is and write all the other three terms in a separate bracket, taking minus common. So you see, inside the bracket, each of the sign has changed, right? So now look closely. This trinomial, it must look very familiar. 4a square can be written as 2a whole square and y as y square. The middle term becomes 2 into 2a into y. That's a square minus 2ab plus b square, which can be written as a minus b whole square, which is 2a minus y whole square. Now we are back in our comfort zone. That's our difference of two squares, right? So we apply this identity once again. So once we add them up, 3x plus 2a minus y, and we subtract 3x minus, but the sign will change. It was minus y. Because of this minus, this becomes plus. And that's it. We have factorized it like a pro. Now tell me honestly, this looked scary at first, right? But once we slowed down and followed the pattern, it was actually kind of satisfying. That's why I keep saying maths isn't tough. It just needs the right approach and a bit of confidence. So that was a little twisty example, but I hope you saw how difference of squares keeps sneaking back into different looking questions. If you caught that moment, drop your love in the comments. Next up, we are going to explore one more twist, and I promise once you get that, you will officially unlock Factorization Level Pro. This one looks wild at first glance, like it's just randomly thrown alphabets at us. But breathe, because there is a pattern hiding here. Step 1, let's open the bracket and simplify it a bit. Now remember what I told you before. When you see two terms like 2ab, try to look around for their friends, that is a square and b square. And when you see 2cd, look for c square and d square. We are basically creating small friend groups in algebra. So I'll rearrange this in a smarter way. So c square, d square and 2cd in one bracket and the negative terms after taking minus common. So please note that signs have changed inside the bracket. So it's minus a square before, now it has become plus a square. It was plus 2ab, which has become minus 2ab, and b square. It was minus b square, it has become plus b square. Now take a close look. Do these trinomials look suspiciously familiar? They should, because each one is a perfect square trinomial. C plus d whole square, and this one is a minus b whole square. The moment we see that minus sign between two squares, you know what's coming, right? Difference of squares identity. So we apply it, and there we go. The scary expression just turned into a neat product of two factors. Now a tiny warning, be extra careful with this minus sign when you're writing the second bracket especially, because that's where most students mess up. So when you're writing this minus sign, the sign over here, because it's binomial, so a minus b will become minus a plus b. So just keep your sign straight and you are golden. Okay, now the next one is like the grand finale of our difference of squares chapter, because at first it looks impossible, but once you know the trick, it's actually kind of beautiful. So let's start rewriting it slowly. First, I'll write this x to the power 4 as x square whole square and y to the power 4 as y square whole square. Now here's the smart move. I'll break 11x square y square as 2x square y square and 9x square y square. So see how I'm writing it? Because I want to form a perfect square first. So the first three terms, that's screaming perfect square trinomial, right? So there we go again. X square minus y square whole square, because this term is entirely a square plus b square, it's minus 2ab. That's a minus b whole square. And 9x square y square can be written as 3xy whole square. So we have reached our comfort zone. Again, difference of squares. So we apply the formula one last time. X square minus y square plus 3xy and x square minus y square minus 3xy. And that's your final factorized form. Looks fancy, right? But all we did was spot patterns and apply identities step by step. And that's it. We have officially mastered type 3 factorization using algebraic identities. From perfect squares to hidden patterns to ninja level differences of squares, you have cracked them all. And don't forget, we are diving into type 4 next, so keep your notes and brains and snacks ready. Until then, keep thinking sharp and stay awesome.